Okay, so let's talk about other things I want you to remember. Another, 1 second. So we said that using a unique pointer like this, integer pointer PTR that equals address of X, and then we can use PTR 0, and when I say PTR 0 equals equals 200, right? Or when I say asterisk PTR equals 200, or of course if I simply say X equals 200, all three lines are doing the same thing. The first two lines are using indirect access to variable X because I already initialized PTR with address of X. And when I say asterisk is basically saying use indirection operator or dereference operator to access memory location specified by pointer and store 200 as brand new value for X. This is doing the old way, the first way we discovered the memory is available to us is by using those square brackets, and essentially doing square bracket 0 is absolutely identical to asterisk PTR. So compiler, by the way, probably converts asterisk PTR to that form in order to compile your program. And then doing something like this would be extremely dangerous because most likely you're saying, okay, I have a pointer PTR which points to an integer in memory. This is variable X that we're pointing to, right? And then it says, and then count 1,000 integers from that address. There is another integer, and so store 200 there. So it's extremely dangerous. It's not appropriate to do things like this in programming. You really have to be careful. That's why when you have a pointer that basically just one pointer that points to a unique variable, you probably just want to use the dereference form instead of using that subscript operator with square brackets, which allows you to specify an index or subscript of the actual element in memory. All right, so but what if I wanted to emulate a function which says a void function that says print message? Okay, and of course what I want is a character pointer to that message, right? And so here I will pretend that I don't know how to use cout. Instead, I will be printing individual characters. Or let's say that I want to print only 5 characters from that message. Right, so I could say message, so I could say std cout print message 0, right? Message 0, print then if I want to print first 5 characters of that message, 1, 2, 3, and 4, right? So those would be the first 5 characters of that message, and then I can maybe add just a hard-coded new line character at the end and be done with it, right? So instead of saying cout message, instead of, let me just do some cleanup here, right? So instead of doing this, what I'm going to do is that I'm going to call my function print message, and this time I don't have to use an address of operator. I simply pass this message because this object message here in function main already stores the address of a character, of the first character. So I'll just say print message and pass this address to that print message function. And of course, this variable message, we already mentioned this earlier, that local parameters, this message is completely different from the one I used in main function. It's just going to look very similar. It's going to be initialized with the same address because I'm just passing the value stored in this message pointer to as an actual parameter to initialize this variable. But then I will try using it. So let's build this. And run it. So it just says today, right? That's all it says. It prints only 5 characters because I'm printing individual characters numbered 0, 1, 2, 3, 4. Of course, in C++, all sequences are zero-based in terms of their numbering sequence. First element is 0 because it's like 0 steps away from message. The next element is 1 because it's 1 step away, then 2 steps away, then 3 steps away, and so it's all zero-based, right? So if I wanted to do this in a loop, right, I could create an integer variable IDX index equals 0 to begin with 0. Then I could, what I could do would be print this use variable as index as opposed to hard-coded number, and have a loop, right? My loop could look like this: while, right? While index, I think I can do it this way. While message index, right, which gives me access to the character, does not equal to the null character, and null character is simply this. Because remember, at the end of this text, there is a null character with all bits set to 0, and this is its character literal equivalent. This \0 specifies that use character and initialize it with all zeros. And for as long as this message index is not that 0 character, I can have this loop, and I can say, basically do this for me. Just send this character out to stdc out. So hopefully this will be doing what I need, right? So I have my index character, and then of course, in order for this to work, I can increment index at the end to make sure that I make my progress through the sequence of characters. So if I build that, and if I run it, now it says today is a good day, and then exits. And but notice that what I was doing, I was printing all of these characters individually, not as a single address of the entire sequence. I went through this loop and was doing this. And if you're taking Java course, you already know that my habit is to begin with while loop, but when I realize that I have a well-formed, well-understood variable that I can be using as the control variable to control when I exit from the loop, I would switch it to a for statement format, for loop, and then my initialization is done outside of the loop. This is my condition, and my increment statement is done at the end, right? And then, of course, this is unnecessary. Okay, so that would be my preference here, to perhaps build it this way. Another way of doing this would be also, remember that we can have, let me just sort of like copy this loop and paste this one more time. so that I will basically be printing it twice if I did this. All I need to do is that I just need to say index should go back to 0, right? The second time I need to use initialization statement, which will reset the index variable back to 0. So this way it should be, if I build this, right, it should be printing my message twice, and it does. That's fine. I have two loops which are exactly the same. But then if I did this, right, if I just if I wanted to use this type of syntax, if I said that I have a pointer and I have an alternative syntax to square brackets access to memory. Square brackets goes to the location specified by message, and then says that far from that message, like based on this index, access that character and everything. But if I wanted to use this alternative, I still could do that, right? This condition should work because dereference pointer is very much like doing this, right? 0. I can check against 0, so syntactically I'm not losing anything, right? So I can do this, and I can also do this and print this character, print character pointed by a pointer like this. And so what's interesting is that if I get rid of index altogether, I can simply be incrementing the pointer, because remember, message here, right here, when we declare message, it's a variable, which is the pointer to character. So you can increment pointers, and it will jump to the next object in memory. So this should be equally working the same way. If I build this, and if I run it the second time, you can see that it just gets printed twice the same way. So which demonstrates that now, because I started incrementing my pointer, notice that the pointer will completely lose its connection with the first character. For a very long time, we said that, oh, when you have string literals like this, it's kind of essential that we remember the first character, we remember where the first character is. Okay, it's essential. This is how we can keep track of the string and use it multiple times anywhere we want in our program. But this time, I went with the second loop, right? With the second loop, I went kind of like unconventional and said, abandon the location of the first character as soon as you print it, right? So we enter here to begin with. This dereferenced pointer points to the first character. We check if it's a null character or not. If not, we print it. Then we go back to the increment statement of our loop, and we increment the pointer and say, abandon the original character, go to the next one. So obviously we say that we essentially consume the values, and at the end, this pointer is probably, you cannot simply go back to where you were. It got modified and now points to the end, right? At the end of this loop, the pointer message here will be pointing to this null terminating right at the end of the character string, right? If I really badly wanted to remember that pointer and be able to restore it, I could say integer pointer ptr temp, right? Like temporary pointer, and say, remember what this message is. Oh, that's not an integer, that's a character. I'm sorry, right? I need to say it's a pointer to a character, right? And remember what that message was. And then if I wanted to restore it, I could just say message, go back to the address of the location that I remembered, right? So that's another possibility, right? So this preserves preserve the location, right? And then we say restore restore the location.